So I want to talk about Photoshop and how Photoshop is actually different from Illustrator. And how we talk about that is when we're dealing with Illustrator, we're dealing with vector files. When we're dealing with Photoshop, we are dealing with raster files. So what does that actually mean? Well, as we start off, we know from Illustrator, Illustrator files are made up of lines and shapes. You can print them any size without any loss of quality because vector is completely scalable no matter what, and you don't lose the detail of the files. You can have a vector file and you can open it up in Photoshop and you can convert it to a raster or a pixel-based file. And the reason why we use vector files is because they are infinitely scalable, and probably one of the best things that you see and relate to that is vector is going to be text. So when you have text on your computer or text on your phone, your tablet, and you zoom in and you zoom out, the text doesn't get to be really pixelated or start to go ahead and look very fuzzy or look bad as you go ahead and zoom in. That's because it's a vector file. It's infinitely scalable, so no matter what size you look at the vector, it's always going to look good. And we use scalable vector now, SVG files, for online content because of their capability to go ahead and scale up or down. Now, if we take a look at a vector file, you can see that when you zoom in really big, the quality of the vector file is going to look the same no matter what size you actually look at it. And it's always going to be clean, it's always going to be crisp, and it's always going to be clear. Now, a raster file is going to be a pixel-based file, and it is made up of squares of color. And when you look at an image in Photoshop, you zoom in, and you can actually see all these pixels that are in that file that basically make up the entire content of the file. And each pixel is its own square of color. And in any given Photoshop file, all the pixels are going to be the same size, and each and every pixel will be its own specific color. So the larger the images that we have, the lower the quality becomes, and we're going to talk about that because as we go ahead and we have bigger files that are stretched larger, they go down in quality, and as you make them smaller, they go up in quality. Unlike vector, they are going to be affected by size, where vector is not. Big or small, vector will always remain clear. And of course, we use Photoshop to go ahead and edit these files. So just taking a look at a zoom in here on what a raster file or a Photoshop file looks like. We take a look, we've got this nice little starfish, we zoom in and you can see all the pixels that are making up this file. Pixels aren't round, they're all square. So when you have a file that is got nice clean lines and very much in focus, it's just packing a lot of pixels of information in there to make it look like they're smooth. There is no inherent smoothness in a Photoshop file simply because it's all made out of squares. And if you've ever tried to make a curve out of squares, it doesn't work like you think it does. So one of the things we have to talk about is how we actually are going to use these images so that we know when we get a file that somebody provides to us, or we take a picture, or we get content from somebody, we have to know how these final images are going to be used in order to be able to understand if we have enough information in this image to be able to use it for our end result. So here's what we do. So somebody sends me an image, or I take an image on my phone or my camera. I need to know where this final image is going to be used. What is its final use? If it's going to be web-based, web-based is a very loose term. It's anything that's going to be on a light emitting device. TV, monitor, cell phone, tablet, display, whatever. That is what we loosely call web-based. A print-based image is going to be something that we actually physically print out or have printed. So a brochure, a flyer, a business card, something that's actually going to be physically printed. And we need to know this because the terminology that we use for something that is web-based and something that is print-based is going to be very specific. And there's lots of things that you need to know about a web-based image and a print-based image that is going to guide you to understanding how much information we have in these images, and how they can be used correctly. So we're going to talk about image sizing. And image sizing has a lot of different components to it. So we're going to jump right in. Sizing something for the web, and remember, web is a very loose term, something that is going to be displayed on a light emitting device. We measure all of our web content in pixels. If somebody tells you that I need a picture for my website that's 2 inches by 3 inches, they do not understand what they're talking about. It is always referred to in pixels. So if somebody asks you to do a web banner or an image or a pop-up or something, they will always say, I need it in X number of pixels by X number of pixels, say 300 by 450. That tells you some very immediate things. One, that tells me that it is based in pixels. Second, it tells me that it will be for the web. Third, it tells me that it's going to be 72 pixels per inch. And fourth, it is going to be in RGB mode, and we're going to talk about color mode. But those are the 4 things that something tells me when somebody tells me, I need this for the web. Measured in pixels, and is going to be 72 pixels per inch, and it's going to be in RGB mode. That's what I know. Now, if I'm going to use something for print measurements are going to be in whatever unit of measure that you work with. We work with inches, so if somebody tells me, I need this for a poster and I need it 8 inches by 10 inches, or a headshot or something like that, that tells me one thing immediately. That tells me that it is not going to be used for the web because we're referring to the final end use in inches, never in pixels. Now, when it comes to go ahead and sizing for the print images should be around 300 pixels per inch. We call this a high-res file. We call web images low-res file or low resolution. So 72 pixels per inch is for the web, considered low resolution. 300 pixels per inch is high resolution that we use for print. We can get by with images that are about 225 pixels per inch if we're going to use them for print, and much more than that, or much less than that, out of that range, we're going to see some noticeable degradation when we go and we print. So these are the things that we need to know. How big do we need this image to be, and where is the end result going to be? Now, if we're going to use something for print and for the web, you always go ahead and build it for print, and the reason why is because you can always reduce the size of the file, because when we're dealing with something for print, we have a lot more information, more pixels per inch, and when we do something for the web, we have fewer pixels per inch, and therefore we can take a print image and size it down. We can't easily take a web image and size it up for print without serious issues, and we're going to talk about that. So let's talk about image resolution. Image resolution is measured in pixels per inch, and a lot of people erroneously say dots per inch or DPI. Dots per inch refers to the number of dots of ink that go on your inkjet printer in order to go ahead and print out your image. Okay? People use this interchangeably. It is incorrect, but we will always refer to this in pixels per inch. That means the number of squares of color that make up 1 square inch of your image. And when somebody says, I have a certain number of pixels per inch, if it's 300, we know it's a high resolution file. If it's 72 pixels per inch, we know it's a low resolution file for the web. And when you refer to pixels per inch, that is basically the content that makes up your image. Now, the more pixels that you have, the more information you get. The more pixels, the bigger the file. Now, what does that mean? Well, you've heard of cameras back in the day of being 2 megapixels, 4 megapixels, 8, 12 megapixels. That just means there's more pixels of information when you photograph something, and more information gives you more detail, and more detail hopefully gives you a better file. You can still shoot an image out of focus, and it still looks horrible, but more pixels gives you more information to work with. So again, a lot of people commonly refer to this as a 300 DPI image. That is actually incorrect, but a lot of people use it incorrectly. So if you want to use this terminology correctly, it is PPI, pixels per inch. DPI is dots per inch. So we talked about high resolution and low resolution. Sum it up very quickly. If we're using it for print, we need 300 pixels per inch. in order for this image to reproduce correctly. For the web or anything that's going to be on a light emanating device, 72 pixels per inch is going to be sufficient for what we do. 300 is considered high res or high resolution. 72 pixels per inch is considered low res or low resolution. So now what we have to do is we have to talk about scaling pixels, images larger and smaller. And so I'm going to jump over into Photoshop and we're going to walk our way through this, but we're going to come back to this here. So I'm going to jump over into Photoshop here, and I have an image, okay? And I don't know how big this image is, and big is a relative term when we're talking about what's going on with a Photoshop image. And what do you mean relative? Well, I see this on my screen. Does it look big? I can zoom in and zoom out. I really don't know how big this image is. So in Photoshop, I'm going to go into the image menu. I'm going to go down to image size, and this is going to tell me several things that I need to know. And the image size is going to tell me that this is 10 megabytes. This takes up 10 megabytes of information on my hard drive. Okay, not a big file, not a small file. If I was uploading this to the web, that would be a really big file. What I'm also looking at here is the dimensions. It's 1536 by 2283 pixels. Okay? Now, if I click on the dimensions here, I can change it from pixels to percent to inches and that kind of stuff. But normally, when we're talking about image size, we either refer to it as how much space it takes up on our hard drive or the number of pixels per square inch here. But the dimensions here are actually measured in pixels, and this gives us millions of pixels. If I were to multiply 1536 by 2283, in fact, let's just do that. Let's just grab the calculator here, and let's take 1536 and multiply that by 2283, and we get 3,506,000 pixels. So 3.5 million pixels makes up this image. 3.5 million squares of color. Okay, 3.5 million squares. That's what makes this up. And this is a fairly small image too. Now, another way we refer to size is what is the width and height at the given resolution. Right now, if I was going to go ahead and use this for print, I have basically a 5 by 7.5 inch image at a resolution of 300 pixels per inch. Okay, so this is fine for print. Can I use this for the web? Absolutely, because the web doesn't require anywhere near the resolution, the number of pixels per inch. So what I'm going to do is I'm going to turn off this resample button, and you'll notice that the width, the height, and the resolution are now all linked together. What happens here? Well, I'm going to show you what happens when we go in and we turn off the resample and we change the resolution of our image from 300 pixels per inch to 72. I've just changed the resolution, and because I've turned off my resample, my width, my height, and my resolution are all linked together. You'll notice my image is now 21 inches by almost 32 inches at 72 pixels per inch. Well, how did it get so much bigger? But here's the interesting thing. The image size is identical. The number of pixels in our image is also identical. We have not changed a single thing. So what just happened here? Well, here's an analogy that may make sense. If I have an image that has 300 pixels per inch, so you measure 1 square inch of your image and you count 300 pixels, okay? My image overall is basically 5 by 7.5. But when I go in and I reduce the number of pixels per square inch, okay, there's no longer 300 packed into 1 inch, there's only 72. What's happened? Okay, well, as the resolution goes down in the image, the overall image size goes up. Well, how does this make sense in the real world? 2 different ways. Okay, if I give you a balloon, and you have a balloon, and that balloon has no air in it, okay, it's a certain size and is a certain density. But what happens when you start putting air into the balloon, you start making it bigger and bigger and bigger, and the balloon gets larger and larger and larger and larger as I make it bigger and bigger as I blow the balloon up. But what's happening? The balloon isn't adding more material to it. What it's doing is it's stretching. And as that balloon gets bigger, it stretches thinner. We're basically stretching the same information over a larger area. And what does it do? It thins out the balloon. Same thing is happening with this image in Photoshop. So the larger I make this image, it gets bigger and bigger and bigger. The resolution goes down because I'm stretching it. Now if I let all the air out of the file, or out of the balloon, what happens? The balloon gets really small and the density, or the resolution, goes way up. Do you notice how my balloon never really changed? It's always been the exact same size. What are we doing here? Well, what we're doing with the resample turned off is we're actually trading size for resolution. So if I take an image and I scale that image up, I am reducing the resolution, the number of pixels per inch, because I'm stretching the whole thing larger. But when I scale that down, I am basically condensing it back together and the resolution goes up. The crazy thing is, I've never changed my file here. Okay, so why is this useful? Well, here's a very useful scenario, okay? Somebody gives you an image and they tell you, yes, it's high resolution. You're like, great, I can use this. But then you realize, oh, no, I need this image much bigger. I need to use this in a poster and I need it to be 24 by 36 inches. Can I use this? I can. Will it look good? No, it won't. Because if I make this 24 inches wide, the resolution is actually so bad that it's not going to even look good on a website. Okay, how do I do this? Well, if I go back in here and I change the resolution back down to 300, and I turn off my resample here, I can now go in and I can make this image bigger. The problem is when I make this image bigger, I'm actually stretching this, and then I'm filling it with information that wasn't there to begin with. So this is like when you run out of money in your bank account. You can't just go into your checkbook and say plus $1,000 and get another $1,000 in your checking account. Because where is that money coming from? Where is it? You're faking it. So with the resample button checked, if I go in and I keep the resolution, and I now go in and I increase the size here, am I making the image bigger? Of course I am. But you notice that I'm also adding a lot of pixels to this image. Well, where are they coming from? Well, Photoshop is basically stretching the image, and any places where there's holes in there, which is everywhere when you stretch it, it's filling it with new information. The problem is when you fill it with new information, you're faking this information, and when you fake it, you can see the results in the end. So if I decided to go in and just make my image substantially larger, like 24 inches, it now went from 10 megabytes to 225 megabytes, okay? Huge. And unfortunately what happens is you start getting a lot of blurriness and a lot of really horrible artifacting in here. So this isn't something that you really want to do, okay? Because you are faking this image. It is so much easier to get an image and reduce the size than it is to get an image and increase the size. It just doesn't work very well. So we're going to come back to this because we're going to show you that there are some times that we need to do this. But I just want to give you this kind of overview of how that resolution works. So jumping back over to here, this is what I was talking about. When you scale up an image, you stretch it larger, the resolution goes down because you're stretching that image over a larger area. When you begin to shrink that image down, the same amount of information is there, but when you scale it down, the resolution goes up because the image is going down in size, the information's getting more compact. Okay. The great thing about scaling a vector file is it doesn't matter. You can scale it up or down and nothing happens with it. That's why fonts are made out of vector. But you know, we can't really make an image out of vector because when we take a picture, it has to be reproduced digitally with those squares of colors. So that's where we run into the issue with images. Now, I want to talk about color modes because color modes are really important. RGB is the visible spectrum of light. So our cameras capture RGB, and we keep it in RGB mode in order to go ahead and display anything on the web. Okay? Anything with a light emitting device stays in red, green, blue, or RGB mode. Okay? Great. However, when we go to print, you'll notice that your color printer has cyan, magenta, yellow, and black, and these have to then be converted at the final stage in order to go ahead and have these print correctly. Light laminating devices do not display CMYK. CMYK only comes from an actual printer. So now that we have some kind of idea here, I'm going to jump back into Photoshop, and I want to talk about our image size here. When somebody gives us something where the file is not the correct size. So the rule of thumb is somebody gives me a file and I need to repurpose it. I'm going to go in here and I'm going to turn off my resample here, and I'm going to see how big I can make this file for my end result and what the resolution I can get out of it. If I'm going to use this for the web, it's going to go ahead and be this size. Now, here's the interesting thing. We don't measure web content in inches, but you'll notice when I go in and I turn off the resample and I set the resolution to 72, and I try to change the name to pixels, or the measurement to pixels, it doesn't work. And the reason why is because what I have to do is, once I set this to 72, I'm going to turn my resample back on. It has not changed the size of the file. It's still exactly the same. But now I can change this to pixels. And of course, it's 1536 by 2283 pixels wide, because that's the size of the image. And this is huge. And you know, if you're doing something, even high res is like 1920 by 1080. I mean, this picture would be far bigger than we'd ever need on a website. So if I needed to get that, I know I've got more than enough information for the web. I'm going to turn the resample back off again, so my width, height, and resolution are all linked together. I'm going to put the resolution back at 300, and you'll see the size now drops down because I am reducing the size of the file and the resolution is going up. Now, what happens if I need a bigger image in here? Well, once I set this resolution to what I want, I'm going to click back on the resample here. And Photoshop knows that there's sometimes you have an image that you just need larger, okay? So if we are going to resample this up, what I'm going to do is choose from the resample section here. What do you want? Do you want to preserve the details for enlargement, or do you want to make this smoother? Here I'd like to preserve the details because the little crunchy bits in the ice cream cone are very important. If I was doing a sky, I would probably do smoother rather than preserve details. Now, I need to make this larger. Now, the rule of thumb here is I really can't go in here and make it 10 times the size. Usually 25, 35, maybe 40, 50% larger is about all you get out of an image. Resizing it larger until you start to see the quality degradation because you're stretching that over a larger area. So when I go in here, and if I need this bigger, I'm not just going to go ahead and yank it up and say, okay, here's going to go from this size to this size. What I'm going to do is I'm going to increase the size a little bit. And I'm just using my up arrow, just by putting my cursor in here and using my up arrow and my shift key. And I'm just going to bump it up in size a little bit with the preserved details there. And you can see it's gone from 10 to basically 20 megabytes. I'm going to click OK. Now I'm going to go back under the image size, and I'm going to do this again. And the reason why is because very much like when you get up and you want to run or you want to exercise, you want to warm up here. So I don't want to just take this and yank it up to a huge size. I'm going to do it little bits and pieces at a time, clicking OK, letting it rebuild, and then coming back and building it up again. Okay, doing this several times until I get to the final size. Okay, now each time I enlarge or even reduce, I am causing some degradation in quality. And here it's gone from my original 10 megabytes, it's already 32 megabytes, and it's only gone up a few inches in size. And that will degrade the quality. So I'm going to back out this, and I'm going to get it back to my normal image size. Shortcut for image size is going to be Option-Command-I. So when I come down here, what happens if I'd like to go ahead and reduce this in size to be for web use? Simple. I could go in here and I could reduce this for web use right here and go down to 72 pixels per inch. And I'd measure this in pixels here. And this is where I could say, okay, here's what I need to do for this image. And maybe somebody needs this 600 pixels wide at 72. Now, because I'm actually reducing the file size, because it's gone from 10 megabytes to 1.5, what I want to do is I want to use the reduction filter. And what this is going to reduce it, because as it reduces it in size, it goes ahead and reduces it down and throws away a whole bunch of information and then puts it all back together. So here, because I'm reducing it, I don't want to just go in and be like, well, I don't know what to do. go in and use the reduction. And here, it's going to drop it down from 10 megabytes to 1.53. I'm going in and putting in my actual width and height in pixels at 72 pixels per inch. And when I click OK, that will give me my image. Now, when I zoom in really big on this image here, it doesn't look so good. Well, the reason why is because when we look at an image on a website, we don't really zoom in on it, okay? I'm at 1600% in size, and it doesn't look very good. But we don't normally zoom in on an image on the web. But some people say, oh yeah, I do all the time. Well, it's interesting because a lot of websites, when you do go and click on something to zoom in, and you click on it, it may load a higher resolution image or a larger image that then allows some type of HTML or CSS or plugin in order for you to zoom in on that image to make it look like you're actually zooming on the original image. You're not. But that's something that we can definitely talk about later. So the images start off at 72 pixels per inch. If I zoom in really big here, you can see that all of this is made up of pixels, and every single pixel is its own individual color. They're all square, they're all the same size, and each one is its own color. There's no gradients in here, there's no nothing. There is no smoothness whatsoever. Even the edge of this ice cream cone has very sharp edges on it. Now, one of the things that you may see when you zoom in on yours is you may see a pixel grid, and you may see that thin little white line around those pixels. It's fine in some cases. It is kind of annoying in other cases. If you want to turn off that pixel grid, it's very easy. Go into the View menu, go under Show, and there is your pixel grid. So View, Show, Pixel Grid. The pixel grid only shows up when you're at 600 pixels per inch or larger. So if you don't see it, it may not be on, but it could also be that you're zoomed out to the point where you don't see it. So jumping back over to our presentation here. So now we know how to size something. Now we know what the resolution is of our image here. Now let's talk about actual file types here, because this is really important. Okay, JPEGs. So if you have a point-and-shoot camera, your format for your images that you shoot are probably JPEG. Okay, JPEG stands for Joint Photographic Expert Group. And JPEGs are used widely because we can use them on the web, we can use them for print, we can basically use them everywhere. Okay, now JPEGs only save pixels, they don't save any raster files whatsoever. If you save a vector file as a JPEG, they're no longer vector because they will rasterize them. Okay? JPEGs, however, have one inherent problem. JPEGs are what's called a lossy format. The reason why people like to use JPEGs is because when you save a JPEG, you can compress it down very small. If you've ever taken a piece of paper and wrinkled it and then tried to smooth it back out when you're done, that's what a JPEG does. It reduces the file size by merging common pixel colors together, and then when you open it back up again, it is permanently damaged depending on how much you compress the file. But JPEGs also have inherent benefits because they contain the full range of the color of the image. TIFF files are something that photographers will use when sending a processed image to somebody to go ahead and print. TIFFs are for print only. They do not work on the web, and TIFFs only save pixel or raster-based files. We don't save vector files as TIFFs because, just like JPEGs, TIFFs are going to be pixel-based. TIFFs stands for Tagged Image File Format. TIFFs are fairly old. They've been around for quite some time. They're still used, but not anywhere near as much. If you never use a TIFF, you will not be losing out on anything. If you do, it's for images. The one benefit of a TIFF over a JPEG is JPEGs lose their quality the more you compress them. TIFFs do not lose the quality. PNGs, Portable Network Graphic. This is great when you're saving graphics, logo, or type from either Illustrator or Photoshop. PNGs are for web only, and the reason why they are for web only is because they are all raster or pixel based. So if you have a vector file and you save it as a PNG, it will never be vector, okay? It will always be pixel based. The reason why PNGs are not good for print is because they severely limit the color palette for your content. Never save an image as a PNG, and don't use PNGs for print either. The reason why is because, one, they're going to be low resolution. You can have a high resolution PNG, but the problem is it cuts out almost all of the color information. That's why PNGs are great for the web. They load quickly, logos, graphics, make them look really good, but terrible for print because they cut down the amount of information and almost always low res. The one benefit is PNGs can be made transparent. JPEGs cannot. GIF file, graphic interchange format, very much like a PNG, older, but works with very much the same capabilities of a PNG. PNGs are considered better simply because when the GIF format came out, CompuServe, which owned this, charged everybody a licensing fee, and PNGs were created in order to get around this little bump. So GIFs are something that are going to be the same as PNGs. They're great for graphics and logos, only for the web. They will only be pixel-based. Don't ever save a vector file. Yes, they can be made transparent, and they also limit the colors to a maximum of 256, if not less, just like a PNG. So GIFs and PNGs, not good for images, and definitely not for print. EPS files, old file format. This was encapsulated PostScript. This was back in the day when a lot of the software companies, software did not talk to each other at all. EPS files were files where you'd save a vector file so that you could go ahead and put it into another application and for it to print. EPS files, very old. I can't think of any benefit to save any of your files as an EPS file anymore. There's much better file formats. SVG, Scalable Vector Graphic. Scalable vector graphics are for vector graphics that are done in Illustrator for logos, type, and graphics, icons, you name it. SVGs can be used for print. We pretty much use them for the web because the benefit is that they do not pixelate like a PNG or a GIF. The great thing with an SVG is that it's infinitely scalable on the web, which is fantastic, so you no longer have to render multiple different images or logos depending on what size you need for your website. You can just simply scale this vector graphic up or down. You can use SVGs for print as well, but if you're going to use something for print, it's better to use a native Illustrator file or a PDF file, just so people don't get confused between the print and the web versions. PDF, portable document format. It's probably one of the most universally accepted file formats because it can register both raster and vector. It can take almost any application, any file type, and be able to turn it into a portable document format so somebody can read it, somebody, if they have the software, can edit it. Now, we don't use these for the web. You can put a PDF on the web, but we can't actually write a PDF into HTML. So it's not a file format that is directly used, but you can view it on the web, on a mobile device, and you can also use it for print. So very versatile, but definitely more in the print and viewing world rather than creating a graphic for a website. And of course, I like to follow this up because a lot of people don't know about digital formats. And this is a fantastic quote from my mom. I don't know about digital formats, but I need to know. So now you know. We're going to jump back over to Photoshop because there's a couple other things that I want to talk about before we get into actually learning about Photoshop. Now, we talked about the different file sizes, and when we're dealing with an image here in Photoshop, one of the things that we want to make sure of is that we have a large enough file to do whatever we want to deal with. When you take an image off your camera or your phone, the larger the image, the better off you're going to be because we can always throw information away. It's very difficult to go ahead and recreate information. So it also takes up more space. So if you take a lower quality image, then you will always be stuck with a low quality image. If you take a high quality image, you can always reduce it in size and you can always throw information away. But a low quality image, you won't have any real use for other than just for basic web content. Now, when we have talked about going in and scaling these images up or down, if you were to go in here and you were to resample this and scale this down here, and then turn off the resample again, and I'm going to use the reduction here, and I'm going to convert this to a much smaller image. Say I'm going to use this on the web at 500 pixels per inch. Okay, 500 pixels wide, 72 pixels per inch. It's gone from 10 megabytes to basically 1 megabyte, and I'm going to click OK. Okay, there's my image right there. Now it looks fine because I'm viewing it on screen. In fact, this is the actual size that the image would appear on the web. It looks fine. But when I zoom in, I notice that a lot of the detail is kind of blurry. Now keep in mind, we're looking at this at 3200%. Here's what happens when I take an image that's way too small and I stretch it too far. If I go under Image, Image Size, I'm going to take the same image. I'm going to click the resample here. If I wanted to use this at print, I'm going to set this resolution to 300. At a high-res file, I would basically have 1.5 inch by 2.5 inch file, and it's like, well, that isn't big enough. So what I'm going to do is I'm going to resample this, and I'm going to make this substantially larger, and I'm going to show you what happens to this image when we go in and we take an image that is very small, and we make it really huge. So, okay, this was 1 megabyte after we reduced it down, and I'm going to make it like 50 megabytes, okay, right there. So it went from 1 to 50. How do you fake that kind of information? Well, Photoshop will. And make sure if you are enlarging this, and by the way, this is enlarging it way too much, you need a better image to start with. I'm going to show you the quality degradation that happens. I'm going to click OK. And now when we zoom in here, you're going to see a lot of just soft blurriness and a whole bunch of color spots and everything. It's like, wow, this is terrible. Right, because what happened was those nice clean edges there are gone. You have taken this and you have stretched it way, 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 way too big, and your end result is going to be a very bad looking file. So if I was going to use this for print at the size that I have zoomed this up to, this is going to look absolutely terrible. Okay, just because we have gone in and we have taken it from 1 megabyte to 50 megabytes. Now this is true if I take this image and I put it into InDesign and I scale it way up, or if I go into Illustrator and I scale this image way up, the exact same thing is happening. I am taking this and I'm making it huge based on the amount of information that I have. I can't fake this information. If I do fake this information, this is exactly what happens. So the rule of thumb is always have images that are bigger than you need. You can always go in and reduce the resolution down. When you reduce it down, you are throwing information away and your file size is getting smaller. However, taking a small or low-res image and blowing it up again doesn't work very well. So, always plan accordingly. If you are going to be using files for both print and for web, always set your print settings first. Make sure you've got that size. You can always reduce the size down for your web. If you have web only and you want to use it for print, you're going to be stuck with a very small image because the resolution will not allow you to make it bigger. So that was a really quick overview of what Photoshop is and what it does in terms of pixels and how we go through and talk about the size.